Our lecture begins now. We are in 8-4. We are studying matrix determinants. Matrix determinants. So determinants, we also saw last class a little bit, but now we're going to go more in depth and we're going to see how we can find the determinant of any square matrix. Quiet, please, boys in the front. A determinant is indicated with this symbol. Kind of looks like an absolute value. So for example, if we have a matrix A, maybe 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, I skipped 4. Then the determinant is indicated by what kind of looks like absolute value symbols. So it looks like that. I should use black, shouldn't I? So it kind of looks like an absolute value, but it's not. And we indicate it, instead of using square or round brackets, we use vertical bars. Okay, so that's what a determinant looks like in terms of its notation. And so the determinant is always a number. So for this matrix, it's actually equal to 0, which we'll calculate soon. Okay? So the determinant is always a number, and a very important thing you need to know, only square matrices will have determinants. All right? Only square matrices have determinants. But at least all square matrices have determinants, unlike inverses in the last class where not all square matrices had inverses. But all square matrices have determinants, so that's the good news. Okay, questions?
Were we expected to do the last two questions on the homework, even though you didn't teach them in class?
Yeah. You knew enough to do it, maybe just... It's okay. Don't worry. I think the email was pretty helpful, so. All right. Let's first review 2x2 determinants. So. I think the last two questions of the homework could have been done with logical inference based on what we've already learned. So.
Could technically everything be solved by logical inference?
Indeed.
So.
Well, not always, because you need to know the right definitions.
I could technically by logical inference discover what a matrix is, like teaching it. But
Well, you can't discover the determinant by logical inference. That's the definition. Okay, 2x2 determinants. We already learned this formula, right?
What the inverse for 2x2?
The determinant for a 2x2 matrix, we must memorize, is AD minus BC. Well, an inverse is an actual matrix. The determinant is a number. They're not the same thing. But we use the determinant to find the inverse, right? We had 1 over AD minus BC and D minus B minus C A. Okay, so you see a lot of similarity with the inverse, right? Guys, you need to be quiet. Okay, this is annoying me. Ruhan. Well, based on what you've been talking about, I don't know that, right? Okay, it's similar to the inverse because the inverse we use the determinant, right? D minus B minus C A. All right, as you guys remember, D and A flip and B and C become negative. So we use the determinant in finding the inverse. So we already know this formula pretty well, AD minus BC. Any questions? Questions? Okay, going on. Did you need that more? Okay. Going on, let's find out how to find the determinant for any n by n matrix. Remember, it has to be square, but we can find determinants for a matrix of arbitrary size, as long as it's square. Let me first show you how to do it and explain how it works, because it'll make more sense like that. Let's say we were asked to find the determinant of our matrix above, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a 3 by 3 determinant. Okay, the formula for determinants that we are going to learn is a kind of recursive formula. You guys all know what recursive means from your computer science classes, right?
Recursive?
Oh yeah, I took that freshman year.
Good.
It means go from
It means that
end to beginning.
to find an m by n determinant, we have to first find several m minus 1 by m minus 1 determinants, and so on until we get down to something we know, okay? So let me explain what I mean. The value of this determinant is equal to positive 1 times the determinant of 5, 6, 8, 9 minus 2 times the determinant of 4, 6, 7, 9 plus 3 times the determinant of 4, 5, 7, 8. All right, anybody see the pattern?
No.
Okay, maybe this is a good IQ test. I don't know. Anybody see the pattern?
Four on the right bottom, and then it's the on the side, and then the one on the left bottom.
Okay, I'll pretend I knew what that means.
Wait, give me a second. Give me like 2 minutes.
I think IQ tests are timed, aren't they? Never taken one though. Yeah.
On the right, like when it's like 5, 6, 8, 9, like are those absolute values?
No, we're finding the determinant of this matrix, of this 2 by 2 matrix.
Okay, so it goes from bottom right to bottom left and bottom right to the bottom left.
Okay, and why?
Because it goes from 1 to -2 to positive 3.
That doesn't make sense to me. Anyways, here's the pattern. Here's the pattern. We're expanding across this row, so we have 1, 2, and 3, okay? But what do we multiply each one by?
I don't know if that's right.
We multiply the 1 by 5, 6, 8, 9, because that's the matrix that's left over when we cross out its row and column. Okay? Make sense? So that's how we get 5, 6, 8, 9. We cross out the row and column that belongs to 1.
And then 2, it's like
How do we get 4, 6, 7, 9?
it's like the T and the limit. Like,
Cross out the row column 2.
Yeah, very good. So for 2, we cross out 1, 2, 3, and 2, 5, 9, and we're left with 4, 6, 7, 9, right?
Wait, but why do you subtract 2?
That's just the formula, okay? And then the formula for the determinant. And then for 3, we cross out 1, 2, 3, and 3, 6, 9, and we're left with 4, 5, 7, 8.
You gotta explain
All right?
why though.
why is it not positive 2?
What is the one?
So this formula is called cofactor expansion.
Just it works because it just works. Don't ask why.
That's right, exactly. It's the definition. It's a definition. Can't explain definitions. It's defined like this.
It just works.
Exactly, thank you.
Why?
Sounds like Fahrenheit
Not a very academic mindset.
Yeah, that's not very accurate.
You don't really understand math if you think everything is supposed to be explained, okay? Some things are just definitions, and we build upon those definitions to understand what math is, okay?
I want to know why it works.
8 equals A.
I have had enough. Quiet, please.
Wait, so listen to the second one always has to be negative?
Yeah, quiet.
Okay, but there's a last thing I need to explain. Where does this plus come from, and where does this minus come from, and where does this plus come from? All right? These have to be adjusted by this pattern, okay? We start with the plus on the top left, and then it proceeds in this pattern, plus, minus, plus. Minus, plus, minus, plus, minus, plus. So it follows a checkerboard pattern of pluses and minuses.
2
Okay.
be negative 2 on the first one?
So it's always positive, negative, positive, negative.
That's right. And we have to adjust them by this factor, by this plus or minus. All right. So the procedure, first, choose a row or column to expand by. So, okay, so just one column to expand by. So in this case, we've chosen the first row, okay? We've chosen 1, 2, 3. Okay? Second, you have to multiply each element by the appropriate plus or minus.
Will it be the same regardless of what row you choose?
That's right. That's the kind of the magic of determinants. Whatever row or column we choose, we'll get the same answer.
If you do it correctly, all 3 will be the same.
Correct. All 6, actually, rows and columns.
It's called math magic.
Very good. Okay, and then thirdly, we have to multiply by the cofactor matrix. Cofactor determinant, that is.
Is there a chance where it would be negative first and then positive, or will it always be positive?
So the rule is that the top left is always multiplied by a plus sign. Okay, and then we determine the signs based on the top left one. All right, so if you calculated this, you would get 0. Okay, that's just what it comes out to. If you calculated all these determinants, which we know how to do, right? You would get 0. Okay, let me show you guys doing it by a different row, okay?
Wait. Equals 0. Doesn't the answer have to be in a matrix?
No. Determinants are numbers. These are all numbers. The determinant of 5, 6, 8, 9 is 45 minus 48. Right? AD minus BC, which is negative 3.
Skipping 7. Got a brain rotten audience, you know.
Yeah, very good.
25.
So
Get it?
you have to multiply the numbers inside by the coefficient first before you get the determinant of the
Numbers inside what?
So like minus 2, 4, 6, 7, 9. Do you find the determinant of 8, 12, 14, 18?
Where's 8, 12, 14, 18?
So minus 2, 4, 6, 7, 9, right? In the middle there? Does that mean that you have to find the determinant of multiply everything by 2? 8,
No.
12?
We're not multiplying the matrix. We have to calculate this determinant and then multiply by 2.
How do you calculate the
Yeah. We just learned that. AD minus BC.
AD minus BC?
All right, so that would be 36 minus 42 here. Okay, let me erase these steps. We don't really need them. And I'll show you how to calculate this. This would be 1 times 45 minus 48 minus 2, Ruhan, be quiet. 36 minus 42 plus 3 times 32 minus 35. And if you did that out, you would get 0.
Wait, why is it plus minus plus?
I've explained that twice already. Okay, let's try expanding with the second row instead. And I'll prove to you guys that it's the exact same. All right? The second row, well, this 4 has to come with a minus sign because it follows that checkerboard pattern, right? The top left is always a plus, which means that the 4 must be a minus. And the 5 is a plus, and the 6 is a minus. So we do minus 4 times the determinant of what? Anybody?
2, 3, 8, 9.
Good. So we got that because what we do is we eliminate the row and column of 4. So we eliminate that row and that column, and we're left with 2, 3, 8, 9. And then I do plus 5 because it's a plus sign, right? And that's 1, 3, 7, 9. And then minus 6,
From the second or first.
1, 2, 7, 8. Okay, questions?
What does that equal?
Pretty straightforward. 0.
0? Okay.
Okay, I can show you. This is negative 4 times 18 minus 24, which is negative 6, plus 5 times 9 minus 21, which is negative 12. minus 6 times 8 minus 14, which is negative 6. And that's 24 minus 60 plus 36, which is 0, right?
So it's just a rule that like the middle one has to be the opposite sign of the other two. Right? Like -4,
2 times
5.
9.
No, the rule is you start with the top left is always positive.
And you subtract.
Just happens to equal 0 right now.
Oh, 8 times, oh, sorry, 2 times 9, 8 times.
Minus 8 times 2.
Okay, one more example, perhaps?
Yeah. Never mind, wait. No, never mind, I'm right.
9 minus 21, yeah.
All right, I'm moving on. Let's do another example. I'm just going to come up with some random numbers. Negative 2, 4, 1, 3, negative 3, 0, 5, negative 1, negative 1. Okay, so let's calculate this 3 by 3 determinant. Okay, and let's first expand with the top row, okay? Let's do cofactor expansion using the top row. You can try yourself, perhaps.
Do we put this on if it's like? If like the thing was positive,
All right, so the signs are like this. This is a plus, this is a minus, this is a plus. So you have to multiply the number by that plus sign or that minus sign. You don't change it to that, you multiply it by a plus. So a negative times a plus is still a negative, right?
yeah.
Yeah. Okay. You can try this yourself. You should be getting minus 2 times some determinant,
Times -3, 0, -1.
minus 4 times some determinant, plus 1 times some determinant. Okay? So the minus 2 doesn't change sign because we have a plus here. The top left is always a plus. But the 4 changes sign because that one must be a minus if we follow that order. And then 1 has to be a plus because it follows the plus minus plus pattern.
Is it in parentheses or in absolute value?
It's not an absolute value or a parentheses. It's a determinant, right? The vertical bar that we discussed in the first slide when you were talking, right, is not an absolute value, but a determinant. Yes. Yeah.
For the numbers inside the determinant, do we also like add the negative?
Nope.
Alright.
Numbers inside the determinant do not change sign. Keep them the same. So the plus and minus and plus signs, those only affect these numbers on the outside that are multiplying. Okay, what is the determinant that is multiplied by negative 2? Anybody? Nobody? Very good. And then 4, 3, 0, 5, minus 1. And then 1 is 3 minus 3, 5, minus 1. Any questions? Yes?
Can you explain more about like the negative positive thing? Yeah, I'm like struggling.
Okay, sure. The rule is that the top left one is always a positive, okay? And then we proceed from that and go in an alternating pattern. So if the top left is positive, that means this 4 must be multiplied by a minus. A minus 1, essentially.
Oh, so like you can be -2 because it's already -2.
That's correct. So we're essentially multiplying by positive 1. So the sign stays as negative 2.
Then the first one in the second row would be -3.
We can do that later, yeah? Okay, so I'm going to keep going. This is minus 2 times 3, AD minus BC, minus 4 times negative 3, AD minus BC, plus 1 times negative 3 minus negative 15, which is 12. All right?
So I thought all these were supposed to be 0.
No. Why are they equal to 0?
I don't know. I thought that's what you said.
I never said that. Okay, so this is negative 6 plus 12 plus 12, which is 18. Any questions? All right, let's try something else. Let's try a different column.
It is 18.
Yeah, no.
Are you suggesting that I'm wrong? It's okay, I'm sometimes wrong, don't worry. But not this time.
What percent this time are you wrong?
Oh, yeah, I did.
1%?
1% wrong?
Yeah.
0.
Like last week I made 3 mistakes, so.
Wait, how? Without us too, it's crazy.
Huh?
He's literally not giving us a chance to correct the mistake.
Wait, Mr. 9. I think third. Why isn't it negative?
Negative 12?
Because you multiply.
It's negative 3
It's
minus
8. That's right, yeah.
negative 3, so negative 3 plus 3.
Yeah, that's right. AD minus BC.
Oh, yeah, okay.
Okay, now I would like you guys to go expand by this second column, okay? We'll see if we get the same answer. Please expand via the second column.
Second column.
5 by 5?
Bro.
Oh my goodness.
Wait, is that like 4?
Okay, so first check the signs. We're gonna have minus plus minus.
Mr. 9, do you think you made more mistakes in the morning or in the
Because you should know how to do it.
Mr. 9?
Yep.
Do you think you made the most mistakes in like the afternoon or in the morning?
Same amount, I think. What?
You do a 5 by 5 matrix.
We're gonna talk about how to do this like in the lecture, okay? That's a bit harder. Yeah. Okay, so we're gonna start with negative 4. Why is it minus? Because the top left is always a positive, right? Which means that the 4 has to be minused. So we're gonna start with minus 4 times the determinant of, what is it? 305 minus 1, right? All right, the reason is because I'm getting rid of this row and also this column. So I'm left with 305 and negative 1. I keep going. Now, minus 3 comes with the plus sign here. So I know the sign must stay the same. So it's minus 3 times the determinant of negative 2, 1, 5, minus 1. Okay, then finally, negative 1 comes with a minus sign, so it has to flip sign. So I'm left with plus 1 times the determinant of negative 2, 1, 5, minus 1. Got it?
It's 3 and 0. Negative 2, 1, 3 and 0.
Oh, that's right. Whoops. Thanks. That's another mistake. 4 this week, I think.
Is that like 1.5% now?
I don't think so. All right, so what am I left with?
Negative 44.
Negative 3 plus 3.
Negative 44.
Should have gotten the same answer. So, what is that?
Negative 44.
No, it's 18. It has to stay the same, right? That's what we're trying to show right now. So your answer must be wrong somewhere. Yeah. Okay, any questions? That's it in terms of the procedure, but I do want to show you some tricks for doing it quicker for some problems, not all problems. What?
Multiplication right up to left down, right up to.
I don't know what you're saying.
Okay, no, so the
minus
3
BC.
minus
There's
1 and
plus,
then
minus,
0.
plus 1. Right.
Let's continue. What if we were given a somewhat large matrix?
Mr. 9, was the problem above 18?
Yeah. It has to be 18 no matter what way you do it. No matter what row you use.
Oh, yeah.
Okay? Let's do a 6 by 6. A lazy one.
Wait, what?
Just kidding. Let's stay with 5 by 5. Just what?
No, we have the third column.
No, we don't have to do all of them. I was just trying to show that it's the same no matter what column we use. Yeah. Yeah.
I'm trying to have this be my head.
You can't. It's not square.
Wait, dang it. No, I'm not asking that. You're
Call to action.
Just coming up with random numbers now.
You need another number on the. No, you're not doing this.
I'm not. It's quite hard to do random numbers.
Just think of the first number.
And the determinant will not be a fraction, right?
Why not?
If you don't have fractions in the matrix, it won't be
Yeah,
a
if you don't have fractions in matrix, then no.
Wait, how do you get ABCD?
There is no ABCD in this one, bro. It's only for 2 and 2.
Wait, all we have to do 3 by 3? See, that's what we're learning right now.
I think you had to do like, there's like 25 numbers in there, so you need A through Y.
So we're erasing it.
Okay, sorry.
Sorry, I erased a few. My bad.
Yeah, what if it's more than 3 by 3?
I'm gonna erase another one. Just to demonstrate the tricks. Okay? Okay, make sure you copy that right. I went back and changed them, so. All right? So, sometimes there are clever ways to do it because we have a lot of zeros. Okay? So the idea is we want to expand using the row or column that has the most zeros. And why is that? That's because if we have a lot of zeros, then we won't have to calculate a lot of determinants. Let me show you guys. Let's say we calculated the determinant using the third column. That's a ton of zeros, right? So what is that going to be? That's going to come out to -1, right? Because it's we start with a plus here because it's plus minus plus. It's going to be -1 times some big determinant, minus 0 times some big determinant, plus 0 times something big, minus 0 times something big, plus 0 times something big, right? And so all of those cancel out. So we don't need to worry about those. Make sense?
Okay, but like, how do you find?
And so all we need to calculate is -1 times the determinant of 0, -6, 2, 0, 3, 0, -1, 2, 0, 0, 1, 5, 1, 0, -2, 3. Make sense?
And how are we finding?
Any questions?
How do we find that?
How?
Yeah.
Do the same thing again. That's why we call it recursive, right?
Oh, so we have to pick another row?
Yep. So now which column do we pick?
-6 or a second column?
We pick the second column. Very good.
Oh my goodness, no.
So what is that going to become? It's going to be equal to, we have to keep the -1 on the outside, right? So it's going to be -1 times +6, right? Because it's a plus and a minus here. So now the 6 has to change sign. So it's going to be -1 times +6 times the determinant of 3, -1, 2, 0, 1, 5, 1, -2, 3. Got it? Any questions? Huh?
And then
6 comes from because I'm expanding via the second row here. And so the -6 comes from here, but it has to change sign because it's in that position. It's in the minus position.
Wait, so
we will have to do 2, 4,
row 2.
What happened that row? 2, 4, -1, 3, 1. It's because they like you know.
All right, I'm going to keep going.
I think row 2 is the same.
Now I'm going to expand via the first column because that has a 0 in it, so it'll save me at least one step.
Like, let's say we're doing.
So I'm left with -1 times 6
Cross out this and this, and then you get
times
so then
3 times the determinant of 1, 5, -2, 3 And then minus 0 times something, so that cancels out, plus 1 times the determinant of negative 1, 2, 1, 5. Got it? So this time I expanded via the first column.
Does it always have to be the first row that you have to get rid of?
No, you could expand via any column you wanted to. Okay? It's a plus 1 because now this is in the plus minus plus position. So both 3 and 1 are positive. They don't change sign. Got it? And so I'm just going to keep going. Now we know how to do this because they're 2 by 2 matrices. And so the answer is negative 6 times 3 times, what is that, 3 minus 10? So 3 minus negative 10, so it's 13. Plus 1 times negative 1 minus 2, which is negative 7. Okay, so what am I left with?
32.
Negative 6 times 32, which is equal to negative 192. So that's my answer.
So do you just like keep doing it within until it gets to 2 by 2?
Yes. So if we didn't have all these zeros, how many matrices, how many 2 by 2 determinants will we have to calculate? Anybody want to do that math? We would have to calculate, I think, 60 different 2 by 2 matrices. Yeah?
Where'd you get 32 from?
39 minus 7.